Hi, this is Algebra 1, Lesson 71. We're going to talk about trinomials with common factors and subscripted variables. We're starting on page 288. So as you already know, as a first step in factoring, we always check the terms to see if they have a common factor. If they do, we start by factoring it out. And when we're talking about factoring as a verb, we always mean divide. Then we simplify any resulting expressions. So we're going to start here with x cubed plus 6x squared plus 5x. And the common factor in all of these terms is x. So we're going to factor out an x, and that leaves us with x cubed divided by x is x squared. 6x squared divided by x is 6x. 5x divided by x is just 5. Okay? We've done that part before, but now we have a trinomial that could be factored. So we're going to continue. We're going to put an x here and make two parentheses for two binomials. Don't forget to leave your x there. And now we're going to look at this trinomial and see if we can factor it into two binomials. We have an x squared, and x times x is x squared, so we're going to put x's here. Both of these terms are positive, so both of the binomials will be positive. So we need factors of 5, which when added together will come up with 6. The only factor of 5 is 5 and 1. And 5 plus 1 equals 6. So we'll put a 5 here and a 1 here, and that would be your answer. Okay, let's factor 4bx cubed minus 4bx squared minus 80bx. The common factor in all of these terms would be 4 and b and x. So we're going to pull 4, b, and x out of all of the terms. So we have 4bx in front. 4bx cubed divided by 4bx just leaves an x squared. Negative 4bx squared divided by 4bx, which would equal negative x. Negative 80bx divided by 4bx would equal negative 20. Okay? Now let's see if we can factor this trinomial. Don't lose the 4bx. We're going to start with x squared, so both of these are going to start with x. We have two negatives here, so we're going to have a negative and a positive here. So now we need factors of 20, which when added together, actually factors of negative 20, which when added together will come out with negative 1. So the factors of 20 are 20 and 1, 10 and 2, and 5 and 4. Negative 5 plus 4 would equal negative 1. So let's put that here. And here's our check. Negative 5 times 4 is negative 20. Negative 5 plus 4 is negative 1. Okay, let's try another one. Here we have negative x squared plus x plus 20. This is already a quadratic expression. We're starting with an x squared. However, we have a negative in front, and although we can factor it like that, it's awkward. So let's pull the negative out. If we've pulled the negative out, that means we're dividing everything by negative 1. So negative x squared divided by negative 1 is just x squared. Positive x divided by negative 1 is negative x. Positive 20 divided by negative 1 is negative 20. And then we just did this trinomial. So we're going to leave the negative in front. That's very important. X squared is going to factor into x and x. we have two negatives, so this is going to be a negative and this is going to be a positive. And we need a factor of negative 20 that adds to negative 1. So that would be negative 5 and positive 4. Negative 5 times positive 4 equals negative 20. Negative 5 plus positive 4 equals negative 1. So that's your check. Okay, let's try this one. We have negative 3x cubed minus 6x squared plus 72x. So the common factor in all those terms is going to be negative 3x. Okay, so let's divide that out of all of the terms. Negative 3 cubed divided by negative 3x is going to be x squared. Negative 6x squared divided by negative 3x is going to be positive 2x. Positive 72x divided by negative 3x is going to be negative 24. Okay? Now we're going to see if we can factor this into a binomial. So we make sure we don't lose the negative 3x. We're starting with x squared, so this is going to be x times x. And we need factors of negative 24. They're going to add up to 2, positive 2. So the factors of 24 are 24 and 1, 12 and 2, 3 and 8, and 6 and 4. We're going to have one positive and one negative, and the sum is going to be positive. So we want the positive number to be the big one. So in this case, it'll be positive 6 and negative 4. Negative 4 times positive 6 equals negative 24. And negative 4 plus 6 is positive 2. Okay, now we're going to talk about subscripted variables. Sub means below or under. Script means writing. So subscripts are writings that are below something. In physics and chemistry, your variables in the equations you use are very rarely going to be x or y. You'll often use subscripted variables to stand for the unknown numbers in your formulas. So we're going to start by using n, which means the number of. And we're going to talk about money. So if we're dealing with coins, we can use n sub d to equal the number of dimes. We can use n sub n to equal the number of nickels. And we can use n sub q, sorry, it's hard to make very clear writing with markers. N sub q for the number of quarters. Now the equations work out exactly the same even though we're no longer using x's and y's. So let's try one. We're going to use elimination to solve 5 times the number of nickels plus 10 times the number of dimes equals 125. The number of nickels plus the number of dimes equals 16. Okay, so we're going to use elimination. So let's multiply the bottom equation by negative 5. So that we will have 5, number of nickels, plus 10, number of dimes, equals 125. And then we're going to multiply this one by negative 5. So we'll have negative 5, number of nickels, minus 5, number of dimes, equals, and this will be 16 times negative 5 is negative 80. Now we're going to add these two together. These cancel, and we have 5, number of dimes, equals 45. Okay, we're going to divide both sides by 5. and the number of dimes equals, whoops, 9. Okay, we're going to check by putting this into both equations. So 5 times the number of nickels plus 10 times the number of dimes, which is 9, equals 125. And the number of nickels plus the number of dimes, which is 9, equals 16. So this is 5 times the number of nickels plus 90 equals 125. Subtract 90 from both sides. And we have 5 times the number of nickels equals 35. If we divide 5 from both sides, we get the number of nickels equals 7. Okay, and that makes sense over here too. We've got number of nickels plus 9 equals 16, and 16 minus 9 equals 7. So the number of nickels equals 7. So that would be your answer. Okay, this time we're going to use substitution. We have 5 times the number of nickels plus 25 times the number of quarters equals 290, and the number of quarters equals the number of nickels plus 2. Since we already have a nice number of quarters equals, we're going to go ahead and start by substituting this into here. So we have 5 times the number of nickels plus 25 times, and instead of number of quarters, we're going to put in number of nickels plus 2 equals 290. Okay, so this is 5 times the number of nickels plus 25 times the number of nickels plus 50 equals 290. We can put the like terms together. So we have 30 times the number of nickels, and we can move this 50 over here. So 30 times the number of nickels is going to equal 240. Divide both sides by 30, and the number of nickels equals 8. Okay, now we're going to substitute this into both of the equations to check. So we have 5 times the number of nickels, which is 8, plus 25 times the number of quarters equals 290, and the number of quarters equals the number of nickels plus 2. Here we have 40 plus 25 times the number of quarters equals 290. Subtract 40 from both sides. And we have 25 times the number of quarters equals 250. Divide both sides by 25. And the number of quarters equals 10. Right? And over here we have the number of quarters equals 8 plus 2. So the number of quarters equals 10. Alright, so that would be your answer. That's it for this lesson. Try your practice problems. Do all the problems from this lesson, and let me know if you have any questions. Thank you.